In this lesson, we will learn about Startup Authority or SOA Record. As you may know, SOA Record of a zone is created by primary zone DNS servers to control secondary DNS servers on how to update the zone. So the learning objectives of this lesson is to understand SOA record settings for itlifeskills.com zone created by GPVDC01. Then we will analyze zone transfer queries and responses between OPVDC01 and GPVDC01 to update the zone itlifeskills.com. And finally, we sum up the lesson with the keynotes. Now let's view the current setting of the SOA records for the zone itlifeskills.com. To do that, we need to double click on the SOA records, and here it is. To understand how SOA records is used, we need to do the Wireshark capture on GPVDC01 and OPVDC01, and we capture it at the moment when itlifeskills.com zone is created on OPVDC01, and we see that as soon as the secondary zone is created, OPVDC01 queries for the SOA records and GPVDC01 responds with its current SOA records. As you can see, these are the settings on the SOA records on GPVDC01 that we saw in the previous slide. Let's now explain the important fields of the SOA record. First of all, it specifies the type as an SOA record for the zone itlifeskills.com, which means each zone has its own SOA record. The next field is a primary server. It provides the name of the DNS server where the primary zone is created. There is only one primary server in standard file zone, but there can be multiple primary servers in AD integrated zone. So in this record, gpvdc01.itlifeskills.local is where the primary zone for the domain itlifeskills.com created. The next field is the responsible authority mailbox. It contains the responsible person record, which points to the mailbox of the zone administrator. So in this record, hostmaster.itlifeskills.local will point to the zone administrator mailbox. DNS time to leave is the setting that tells secondary DNS servers how long to catch the SOA record before requesting a new one. Based on the time to leave, OPVDC01 will store the SOA record in its cache for 1 hour before requesting a new one. The most important field to control zone update is the serial number. The serial number of the primary DNS server increases by 1 if there is a change in the zone. By comparing the serial number in the answer from the primary server with its own serial number, the secondary DNS server can determine if it needs to request the primary server for update. In this example, if OPVDC01 finds its serial number less than 2, then OPVDC01 will request GPVDC01 to update its DNS records for itlifeskills.com zone. Refresh interval determines how often a secondary server should check with the primary server for the updates. So in this example, OPVDC01 queries GPVDC01 every 15 minutes for the SOA record to see if there is a change in the zone itlifeskills.com. The retry interval controls how long a secondary server should wait to request a new update if it failed to receive the updates from the primary server in the last request. So in this example, if our PVDC01 does not receive the answer from GPVDC01 for its update request, our PVDC01 will wait for 10 minutes to request for another update. The expire limit is the total time a secondary server should wait for the updates from the primary server before it stops responding to queries for the zone. So in this example, if our PVDC01 does not receive any responses from GPVDC01 for 1 day, it will stop responding to queries for DNS records for its itlifeskills.com zone. Let's continue with the zone transfer process. In this case, the zone itlifeskills.com has just been created on OutPVDC01, so OutPVDC01 requests to transfer of an entire zone. As you can see, the type is AXFR, which means it requests to transfer of an entire zone, and GPVDC01 answer with all the DNS records in its itlifeskills.com zone. Here are all the DNS records currently created on itlifeskills.com zone on GPVDC01. These records will be created in itlifeskills.com zone on OPVDC01. To make it easier to check DNS configurations on multiple servers, we can connect them into the same console. Let's connect our PVDC01 to this console. To do that, we need to right-click on the DNS, then click on Connect to DNS Server. And here we select the following computer, and then we type in the name of the DNS server. In this case, it is opvdc01.hq.itlifeskills.local. Then we click OK. Now we can view DNS configuration on opvdc01. Before continuing with the zone transfer process, let's check the serial number on the SOA records of both server GPVDC01 and OPVDC01. To do that, we need to click on the zone itlifeskills.com on GPVDC01, then double click on the SOA records. Let's do it. Here is the SOA records on GPVDC01. Currently, the serial number is 14, and as you can see, it allows us to update because it is a primary zone. Let's do it on OPVDC01 with the same process. And here is the SOA records on the OPVDC01, and the serial number is also 14, which means it is up to date. However, it is grayed down and does not allow us to change because it is a secondary zone. Let's close this records. Now let's start the Wireshark capture on both servers GPVDC01 and OPVDC01, then add two DNS records on itlifeskills.com zone on GPVDC01 to see how the zone transfer happens on both servers. To do that, we need to right click, then click on new host. Here we type in the hostname chaining.itlifeskills.com, then type in the IP address 10.0.0.100, then click add host, then click OK. Now we type in the new host name sales.itlifeskills.com, then the IP address is 10.0.0.101, then click add host, then click OK and click done, and that's it. From the Wireshark capture, we see that as soon as the new DNS records was added, GPVDC01 sent a zone chain notification message for itlifeskills.com zone with the serial number increased to 15, and OPVDC01 sent a zone chain notification response back for the same zone itlifeskills.com to inform GPVDC01 that it updates the serial number to 15 with no error. Next, we see that OPVDC01 requests an incremental zone transfer. As you can see, the type is IXFR, which means it requests an incremental zone transfer. Then GPVDC01 answer with all the DNS records in its itlifeskills.com zone. So in this case, GPVDC answer with all the DNS records, but it may also instead respond with an incremental data which comprise two lists, one of resource records that are deleted and one of resource records that are inserted. Also, a modification to a resource record is represented as a deletion followed by an insertion. Zone transfer is entirely client initiated. Let's check the serial number of the SOA records on itlifeskills.com zone on both server GPVDC01 and OPVDC01. Here is the SOA records on GPVDC01 and the serial number is 17. Let's check it on OPVDC01 and it is also 17, which means the zones are up to date and the serial number is 17 after all the modifications. This is the end of this lesson. Let's read the keynotes